Radical Dude here, and today we're going to be talking about the letter E, but not for the alphabet, in mathematics. It's a fantastic number and it's really long. It starts off with 2.718, and then I think there's a 2 and an 8, and then it runs away. It was discovered mostly by two guys. One was named Napier, who used it in logs, which you could check out my video on that, or it was done with the Swiss mathematician Euler. His name is pronounced Euler, and he decided to use the letter E. He said it wasn't because of his name, but I don't believe him. Okay, so let me just show you one thing about E really quickly. If I were to graph this, if I were to graph y equals e to the x, and it comes out like that, right? Well, guess what? At the point 0, when x is 0, right? This is the x-axis. When x is 0, the slope of this line is 1. The slope is 1 at this point. I wasn't that impressed either. All right? But something that I was impressed with was compound interest. Compound interest. Money. Let's use money. Everybody uses money. I'll try to keep it simple, so we'll deal with teacher salaries. So just say you have $1, right? A nice dollar. And you want to put it in a bank. And one of the banks, who's extremely generous, says, I'm going to give you 100% interest on that after a year. 100% interest. That doesn't happen. The banks are like 1%. They might not even give you any interest. But just for the sake of this example, let's say it's 100%. So you take your dollar, and now we're going to add our interest to it, and it's 100% of $1. Well, what does that come out to? Well, this is $1 plus 100%, if you write as a decimal, is 1. So it's 1 times 1, which comes out to $2. Here's your dollar symbol. By the way, where did the dollar symbol come from? This great country I like to call the United States. United States. That's another subject. So just say you get $2 after a year. Wow, that's pretty good. And some other bank says, you know what we're going to do? That bank only does it once a year and checks your interest. We're going to do it twice a year. But since it's 100% for twice a year, then we're going to do it 50% for 6 months. Every 6 months. Now let's see if that's a good deal. So you're going to have 6 months. The first 6 months. And then the second 6 months. And let's see if that is a better deal. Well, this, you start with your dollar, and this time we're going to do 50% of your dollar. Well, 50% of your dollar is 50 cents. So you're left with 1 1/2, which is the same thing as $1.50. Right? This is $1, that's half a dollar, and 1 1/2 is $1.50. Now this is compounded. That means we're going to take this new money and do it again for the next 6 months. So for the second 6 months, you have your new $1.50, right? Plus, you're going to do 50% of that $1.50. Right? And it's going to come out to $2.20. So you're actually making more money if somebody does this again, 2 times a year. Now let's try to write a pattern to it. Well, this $1.50 is 1 plus a half. So this is the same as 1 plus a half. Right? And this 50%, if you get 50% on a test, you got half the questions right. And then this $1.50 is, right here, 1 plus a half. Now watch this. I can factor 1 plus a half out. When I take this right here, this sum, watch what I do. I take out 1 plus a half, and what am I left with? Well, 1 plus a half times what is 1 plus a half is just 1. 1 plus a half times 1 is this. Plus 1 plus a half times what is all this? Well, all you're left with is a half. So in essence, this is the same as 1 plus 1/2 squared. That's the condensed way of doing this. Okay? That gets you your 225. So if now another bank comes up to you and goes, hey, you know what? We're going to do it 3 times a year. Well, what you do is you follow this pattern, but this time you're breaking up your dollar into 3 parts. You're breaking it up into 3 parts, and you do it 3 times to the 3rd power. And that comes out to 237. Now these numbers are running on, I should say. I'm just rounding it off. And you can do it, another bank says let's do it 4 times, which is quarterly, or let's do it monthly, which is 12 times. So I wrote it out here. This is what's happening. If you do it quarterly, you're doing it 4 times a year. So it's 1 plus 1 over 4 to 4 times a year. If you're doing it monthly, that's 12 times a year. Weekly, that's 52 times a year. Daily, there's 365 days in a year. If you want hourly, well, it's 365 times 24, which is 8760, and you get this. These numbers run on, but I truncated them because we were talking about money. But if you look at this last one, if you let the number run, what's going to happen? Well, this is hourly, and then you can break it to minutely, secondly. Each bank is competing because they want your money in it. If you want to do it continuously, here's what happens. The way you can do it continuously is you have to take a limit as your number is approaching infinity, which just kind of looks like an 8 that drank too much and fell over. And what was the thing we were doing? We're doing 1 plus 1 over n to the n power, right? You divide by how many times you're compounding it, and then put it to that power. And this, my friends, comes out to e, which is a constant. It's just long. It's amazing. And there's one other thing I just want to show you really quickly. One of the greatest formulas in math is this one. It's amazing because it has e, it has the irrationality of pi, it has imaginary numbers in it, I, it has the integer 1, and it has 0, which is the number of times my ex-wife ever loved me. Beautiful formula. Doesn't end well. This has been Radical Dude, and I hope I was able to teach you something. Thank you.